In this video, I am going to translate the function y is equal to x squared to get to this new function y is equal to negative 2 times x minus 1 whole square plus 3. Let's start off with y is equal to x squared, which is this function in blue. It goes to the origin, vertex is at the origin at 0, 0. Now we are going to translate this function step by step, and ultimately, or at the final stage, we are going to get this function as we are expecting. Let's first start off with the easy one, x minus 1 whole square. So look at this portion only, x minus 1 whole square. We should be asking ourselves the question, is it an inside change or an outside change? It's an inside change, meaning the change in function is under the square. So that means under the square. So the effect of this is moving the original function to the right by 1 unit. We are subtracting 1 inside the square, meaning we are going to shift or move the function to the right by 1 unit, or the graph of the function. So the new vertex is going to be at 1, 0, and it's going to be the exact same thing. Of course, my sketch is not going to be exact. So this is how it's going to look like. This is my y is equal to x minus 1 whole square. Remember, inside change makes the function, graph of the function, move horizontally, either to the left or to the right. If it's a subtraction, as it is in our case, it's going to move to the right. If it's an addition, it's going to move to the left. So now let's call this function my y1. y1 is equal to x minus 1 whole square. Now the next thing I'm going to do is find a new function which I'm going to call y2. y2, the difference between y1 and y2 is that I'm going to multiply y1 by 2. Basically 2 times x minus 1 whole square. The effect of this multiplication by 2 is basically taking this green function, green graph, and stretching it vertically. So it's going to look skinnier. That's what it is. Okay? So by multiplying the function x minus 1 whole square by 2, you are having it move faster vertically. That means go up faster. How fast? Twice as fast. As a result, the new graph shrinks, meaning it looks skinnier. It's a vertical stretch. So I've got to this point. Now I'm going to create a new function which I would call y3, which I'm going to write here. y3 is equal to, the difference between y2 and y3 is that I'm multiplying y2 by negative 1. That means it's going to be negative 2 times x minus 1. Now remember, multiplying a function by negative 1 has the effect of reflecting it about the x-axis. So what's going to happen, we are going to take this graph and we are going to reflect it about the x-axis. This is how it's going to look like. Okay, sorry, there should be a square here. So y3, this y3 is represented by this sketch. Now we are almost there. We are up to this. At this point, we just need to add 3 to the function. Now if I add 3 to this function, to y3, then I'm going to get my desired y. Let's add 3. If I add 3 to this function, is going to be an outside change. Remember, inside change and outside change. Outside change makes a function move vertically. So what's going to happen, adding 3 is going to be having the effect of taking this function and moving it vertically by 3 units. Okay, so now let's go ahead and go from here to 1, 2, 3. So right here we are going to be right here, the vertex is going to move right here, and the coordinates of the vertex is going to be 1, 3, and is going to be the exact same thing going down. That's what it is. So this magenta function, which is going to be, let's call it y finally, my y4 or y, let's put it y4 is equal to y is equal to negative 2 times x minus 1 whole square plus 3. That's what it is. So we have started off with this y is equal to x square function, and through translation we came to this final function. This is how you would do it. When you are practicing it, it's a good idea to do these sketches on separate xy coordinate. I was able to use different colors here to distinguish things, but it's harder to do so on a piece of paper if you're using pencil or pen with one color. So doing it step by step helps you see things, and as you go through the steps, always label the vertex. Always label these vertices. Okay, that would help you keep track of things. I hope that this discussion was helpful. Thank you very much.